Okay, so we're going to calculate the number of chlorine atoms in 10 mils of dichloromethane. So the way that we're going to start that is we're going to need to figure out how many grams of dichloromethane we have. So we can do that using the density. So we can multiply our volume of dichloromethane, in this case 10.0 mils, by the density, 1.325 grams per mil. So this is going to give us our number of grams of dichloromethane. From here, we'd like to calculate the number of moles we have. Anytime we're trying to figure out number of atoms or anything like that, we're going to need the number of moles. So in this case, we're going to divide this number up here, which is our number of grams, by the molar mass, which in dichloromethane's case is 84.933 grams per mole. Okay, so now we would like to figure out how many molecules of dichloromethane we'd have. So we can do that using Avogadro's number, 6.022 times 10 to the 23rd. And this is in units of per mole. So that gives us the number of molecules of DCM that we have. So the next thing that we need to do is to look at how many atoms of chlorine that we have in our dichloromethane molecule. So we can say 2 chlorines per 1 DCM. So now we can go ahead and multiply everything through here, and we can get that this above here equals 1.8789 times 10 to the 23rd chlorine atoms. Now we're not done yet. We need to use our significant figures. So in our problem, we were given that 10.0 mils of dichloromethane. So that means that we have 3 significant figures to work with. So 1, 2, 3. So we're going to round 1.8789 up to 1.88 times 10 to 23rd. And that's how we do it. That's how we solve for the number of chlorine atoms in any molecule of DCM. So we could do the same exact thing here. Say we wanted to figure out the number of carbon atoms in DCM. So we could then do this exact same method here. It doesn't change. The only thing that changes is our ratio here. So if we were looking for the number of carbon atoms, we would say that there are 1 carbon atoms per 1 molecule of DCM. We could likewise look for the number of hydrogen atoms. In this case, there's 2 hydrogen atoms per 1 DCM molecule. So our ratio here would be 2 to 1. And it's as simple as that.